Okay. Hello. I'm Donatas from Lithuania, central jamming point. At the moment, working as a system engineer at the Hostinger, software engineer at NetDev / open source routing. One of the co-founders of Baltic NOG, which is established this year, and an active FRR contributor and maintainer since 2019. I was thinking what to talk about and decided that people might be interested to hear something not very popular. Random features recently pulled into FRR, and some BGP capabilities, some ITF drafts. There are 3 hot prefixes at the moment: 0/8, 127/8, 24/4. And while IPv4 is still in demand, there are proposals to shrink these spaces and release millions of IPv4 addresses. From 0/8, there is a proposal to leave only a single address, which is 0000 as reserved, and others should be released. From 127/8, there is a proposal to leave 127.0.0.0/16 as reserved, and 240/4 as it is. So roughly around 300 million new IP addresses on the market. If I recall correctly, Red Hat, or to be more specific, MetalLB, asked some time on how to peer in FRR using 127/8 subnet. At that time, it looks a bit useless, but now I find it very useful, especially when testing interoperability issues between different vendors. Something like running multiple BGP implementations on the same box. It's disabled by default in FRR, but there is a command called allow reserved ranges. Some companies are already using 240/4 internally, especially cloud providers, huge. And one fact fun that I know at least one company which is using IBM's ranges internally. Traditionally, BGP requires specifying whether the peer is internal or external by using fixed AS numbers. AS numbers are advertised in BGP open message directly inside the packet, inside the open message header, or encoded inside the capability if it's 4 bytes ASN. And in FRR, there is a way to say whether the peer is internal or external without using AS numbers. And since 10.2 release, there is a way to say it's just auto. That reduces configuration overhead, makes more flexible, and especially useful in environments where AS numbers can change, like migrations, I don't know, ASN merges, automation, and combined with a number at peering, it's beautiful. The main issue with the unnumbered or interface-based peering is that once you have multiple vendors, most likely you will experience interoperability issues. And one of these is IPv6 link local address handling when the implementation sends 32 bytes next hops. And the real problem is when the BGP node tries to handle global unicast address, which is filled with a link local address, or global unicast address is empty, but next hop length is still 32 bytes. And this capability eliminates the problem by sending only 16 bytes next hop, only a single IPv6 link local address. And good news is that this draft is already adopted by TF IDR working group, and hopefully get some progression. To be honest, this is one of my favorite things that is going to happen in BGP, hopefully. BGP capabilities are advertised in BGP open messages. So in order to modify some parameters, let's say changing graceful restart value, timer values, or peering role, or enable, disable some random capabilities, you have to drop the session, which may damage all the services relying on top of BGP. And this capability would facilitate non-disruptive capability changes by BGP speakers. Actually, it's a new BGP message type, number 6, which is used to advertise or withdraw capabilities dynamically instead of using in open messages. Unfortunately, it's not very popular among the vendors because it's not yet a standard, but in FRRouting it's enabled since 10.1 release, but only for a data center profile. BGP doesn't use IGP metric for best path selection and primarily relies on AS path length. And using IGP, each link has a metric, and the path between the nodes has a distance, which is the sum of the metrics of all the links that belong to the path. And this is a new optional non-transitive BGP path attribute, which is used to carry accumulated distance between the nodes. And when the node receives a route with this new AIGP attribute, the node can enable best path selection based on the AIGP metric. That means that the lowest AIGP metric wins, and instead of relying on the AS path length. Bad news is that this is a non-transitive. That means that it cannot be transmitted between external peers. But there are at least a couple of ways to do that. One would be using set metric AIGP with the route maps. That technically converts this attribute into med attribute, which is transitive. Or another way would be using OID peering. What is OID peering, or what administrative domain peering? Some networks span more than one autonomous system and require more flexible way to propagate path attributes. It's worth saying that these multi-AS networks belong to a common administrative entity. RFC 7938 perfectly defines how eBGP is used at large scale. And these large-scale networks actually require to have an ability to carry any BGP path attribute between external peers that belong to the same domain. This draft defines a new eBGP peering type. It's called eBGP OID. Actually, it's nothing else than a regular eBGP, except that treating path attributes more or less the same as for iBGP. Like on the previous slide, I mentioned that AGP metric is not transitive. So with OID peering, we can send this attribute. Also, we can send local preference between eBGP peers. BGP at path capability allows the advertisement of multiple paths for the same prefix without replacing any previous ones. And a large number of prefixes may be received by a node, potentially depleting memory or CPU resources, or even causing network-wide instabilities. And for example, in a FRR, roughly one path is around 250 bytes. So if we have a full feed, let's say it's a million route, it's around 250 megabytes. And imagine if we have one path, 100 paths per prefix, so it's 20 gigs or so. This extension or / capability allows indicating the maximum number of paths per prefix the receiver is capable to receive, so the sender can send as desired. At path capability itself has a flag to disable receiving additional paths. Something like the receiver can ask, I'm not interested into any additional paths, don't send me any. While with this extension, we can ask, send me only 2, 3, 4 best paths instead of 100, for example. In modern data center environments, we tend to have conventional routers participating in the data center routing process. And the fleet of routers has different versions of routing daemons. That means that knowing the exact version of the routing daemon could be a crucial factor by quickly identifying the root cause. I think it is especially useful for today where AI is involved. We can give for example, a PCAP file, and the AI could give us a quick summary or so what's going on the network, and depending on the version, about the known bugs or features for that version. Yeah, I heard a lot of concern about that regarding the security, etc. But something like a trade-off. It's currently implemented in quite decent number of open source and even not open source implementations, including tools like Watershark. It's enabled by default in FRR, but for iBGP, that means for internal BGP. And there are actually a draft in IETF currently which defines on how to transmit LLDP or CDP information in BGP, but it's just a native way to do that in BGP. Normally, BGP must send a notification message and drop the session in order to handle error conditions. And graceful restart mechanism requires that normal BGP procedures be followed when a notification is sent or received. And this extension capability allows graceful restart procedures to be applied when a notification is sent or received, or when the whole time expires. That means that if both peers have this capability negotiated and notification bit is set inside the capability, the nodes can retain each other's route if notifications received. But this functionality actually can be defeated by using a notification message called hard reset. Other messages are referred to graceful reset, and hard reset is just another type of notification message, which is something like an encapsulation of the original message. So when the node receives a hard reset notification, it just decapsulates it and to find the actual original notification message, which is sent as a init message. In FRRouting, there is also another useful configuration knob called BGP hard administrative reset. That means once you do a manual session clearing, like clear IP BGP, the nodes can retain each other routes as well until the session is reestablished. When the route is propagated beyond the immediate peer, it's useful to allow certain characteristics to be forwarded further. And this is a new, quite fresh draft in IETF as well, that called BGP next hop dependent characteristics. One of the characteristics currently implemented in FRR is BGP next hop nodes, which is already in 10.4, more to come in 10.5. In this diagram, R2 and R6, for example, can send next BGP identifiers to R1, as you can see here. And for now, it's only for visibility purposes, but it might be possible to do something like weighted ECMP based on the number of next hop nodes, or something similar to what link bandwidth extended community does, but with more visibility and fine-grained control. Actually, a better example would be using a closed topology where every path has an equal distance. And if we have a next hop and next hop pair, we can just avoid sending the traffic over the congested links or reducing the traffic ratio. I think that would also be useful for AI networking at some level. Yeah, I think that's it from my side.
Thank you very much, Donatas. Questions? There are a few questions, so don't run yet. I'm coming with the microphone.
Tor Andersson, Red Pill Pro. I'm we are using the BGP unnumbered feature of FRR extensively, where you transport both IPv4 and IPv6 routes over and link local only IPv6 next hop and with automatic peer address discovery, which is super useful. And I would hope that that is supported by more vendors for so that I could use that to my peers and IP transit providers and so on. So I was wondering, this issue about having a 16-bit next hop versus the 32-bit next hop, is that a blocker for standardization of the BGP unnumbered feature? And if that actually...
You mean a blocker from ITF?
Yes, because as I understand, the RFC mandates that the global IPv6 address is put into the next hop, 32-bit next hop field. And of course, if you have only link local addresses, there's no global address to be put in that. So you mentioned that there is a draft to make 16 byte next hops, and would that then remove the requirement for a global?
Yes.
And would that then pave the way for standardizing the BGP unnumbered feature, where you have automatic, as in that you can actually pair on link local addresses in a standardized way? And is there any efforts underway you think that you're aware of that would standardize that feature?
So are you referring to the case when, for example, we have a number of peerings and this capability? Let's say we are sending 16 bytes next hop.
And link local only, right?
Yeah, and on another side is using, for example, set roadmap, prefer global. Are you about that?
I think my question was more, is it possible, or is there any efforts underway for this peer link local address auto discovery using router advertisements to standardize that behavior? Because it is super useful. It would be very useful if Cisco and Juniper and all of these vendors of network equipment would support it, so that when I connect to a transit provider that uses Cisco routers, for example, that we could just do interface-based neighbors instead of just using manually assigned IP addresses on the BGP neighbors. So I don't know if there is any efforts underway to standardize this or not that you're aware of.
I think the draft is already in a good shape, but yeah, contributions or the comments like yours are welcome. So I think we can discuss about that. And
thank you.
Thank you, Tutura. Any other questions? I think no. Thank you very much, Donatas.